Alright, so today we're going to review the rock and mineral quiz. This is what the exam looks like. So I'm going to give you the answers to these. So number one right here, this is actually a piece of quartz. So Q-U-A-R-T-Z, so it's just plain piece of quartz. At the bottom, it's nice and flat, almost looks like it's been cleaved, but it's not cleavage, it's been cut by a saw. So quartz does not have cleavage. This mineral, however, does have very good cleavage. This is called basal cleavage. This is muscovite. This is number two. Muscovite, very silvery, shiny, has a very vitreous luster to it. Nice and shiny. This is muscovite. M-U-S-C-O-V-I-T-E, so muscovite. Its cousin, another mica, another one of the mica family, is this one here. This is biotite, B-I-O-T-I-T-E. Biotite also has cleavage, basal. This is a thicker piece, but these minerals do flake off in nice little thin sheets. A mineral that's extremely heavy is this one here. This is number 4. This is galena. Its chemical formula is PBS. And so galena is a metallic mineral. It also has cleavage. It has cubic cleavage. And so galena. The little white mineral on top of it is calcite. Well, I didn't expect anybody to know that. Just the mineral galena. This mineral here is kind of unique. It has on it striations. So on the cleaved side, there are fine little lines. I don't know if I can get the camera at the right angle to show the striations. I'll try and... But if you put it in the right light, you'll be able to see striations. There are striations, but I don't think the camera's picking them up. So if you see a mineral that has striations, really thin lines, look like they've been cut by a laser, that is plagioclase. And that's what this mineral is, plagioclase. It's the gray plagioclase. Plagioclase also comes in white. This mineral here reacts to acid, number 6. It has 6120 cleavage. Notice the sides aren't like a perfect little cube. It's called 6120. So this is calcite, C-A-L-C-I-T-E, so calcite. Number 6. Number 7, this mineral is nice and cubic, almost translucent, not quite transparent, but translucent. This is cubic, has cleavage, it's halite, H-A-L-I-T-E. If it had impurities in it, it would be rock salt, but this is pretty much the pure form of halite, and so that's halite. Number 8, a mineral that comes in various colors, very colorful mineral. This is fluorite, F-L-O-R-I-T-E. It comes in purple, it has this nice little octahedron shape to it. It can come in greens, blues, all sorts of colors. Fluorite is very well cleaved, and it comes in various colors. One that everybody should be very familiar with, this is number 8, or number 9 I should say. This is pyrite, P-Y-R-I-T-E. These are little clusters of a crystal form we call pyrohedron. You'll often see pyrite also in cubic form and octahedrons. So that's pyrite. Go on to number 10. This is one of the very important rock-forming minerals. This is potassium feldspar, or K-spar. The reason we call it K, because on the periodic table, potassium has the abbreviation of a K. So that's potassium feldspar. Okay, now to igneous rocks. The first igneous rock has a couple of names. It can be called scoria, or it can be called vesicular basalt. It's got air holes in it. That makes it vesicular basalt. Number 12, this is a porphyritic basalt. It's got very large pieces of amphipole in it. The background mass is aphanetic. It's kind of like a greenish gray color. This is very, very mafic rock, high in iron, as evident by the black mineral on here. So the black mineral is amphipole, high iron content mineral. Number 13, this rock here is what we call intermediate. It's not mafic or felsic. It is intermediate. So half the minerals in here are amphipole. That's the black mineral. And then the white mineral is actually plagioclase. So that's what we call diorite. Number 14, this is a porphyritic granite. It's porphyritic because of the very large phenocryst of potassium feldspar. This is porphyritic granite. Number 15, a very light rock full of air holes, and basically it's glass in texture. Its texture, we actually call it frothy, kind of like a foam, because that's what it was. This was a piece of obsidian that had an awful lot of gas, most likely carbon dioxide, and as those gas escaped the obsidian, they stretched it out and formed it into pumice. So pumice will float on water, full of microscopic holes. Number 16 here. This is actually what we call an extrusive rock. This rock formed the surface. This is a rhyolite. So rhyolites don't have any visible minerals in them. We call this aphanetic. Has no visible minerals. So this is a piece of rhyolite. Number 17, very glassy. This is obsidian. So there's a piece of brown obsidian here and a piece of black obsidian. So obsidian has that glassy look to it. So anytime you see something that looks glassy, igneous, it has to be obsidian. Obsidian is felsic, even though it's black in color, but it just took a small amount of iron to get in there to make it into this mafic looking rock that's actually felsic. Number 18, this is definitely a very felsic rock. The silver mineral that you see on here is muscovite. All very large minerals. So when you see a bunch of large minerals like this clustered together, so over here we have some potassium feldspar. There's some quartz in here. This is a granite pegmatite. So it's a pegmatite granite and it's felsic. And number 19, just by mistake, we put in another piece of obsidian here. Actually, pumice. It was obsidian at one time, so this is another piece of pumice. This one's just a little bit more finer grain. So in lab we generally have two pieces of pumice. We'll have a dark gray one and a light gray one. So now we're going to go to the other side of the room here and look at the last igneous rock. Then we'll start with the sedimentary rocks. So the very last igneous rite has visible minerals. This is phaneritic, has visible minerals. They're all dark, so they consist of things like plagioclases, the dark plagioclases. This is a piece of gabbro. So gabbro, you can actually see the minerals, very dark though. So now we're in the sedimentary rocks. This one here is a very fine grained rock. This is what we call shell. You can call them clay stones or silt stones, depending if they feel gritty or smooth. So smooth feel is actually a clay stone. Gritty is more like a silt stone. So that's a shell. Number 22 here. This is a piece of coal. So this is what we call bituminous coal, or the sedimentary variety of coal. And what separates it from the metamorphic variety of coal is by the time the coal becomes metamorphosed, it loses the sulfates, so it becomes more pure carbon. And then this next rock here reacts to acid. So this is a carbonate. This is a limestone. And because all these little fossils in here, we call this phospholiferous limestone. A lot of fossils in this, very apparent. Number 24, we have another sedimentary rock. This is a shell. There's a pile of shell here. So these are all shell rocks, very flat, cleaves off into flat pieces. This actually is part of the formation of the bright angel shell. This formation is very famous for having trilobite fossils in it, Olanellas to be exact. The next rock here is a piece of coquina. So coquina looks like a bunch of broken up shells all glued back together. And that's basically what it is. This is probably the state rock of Florida. You find a lot of this. This piece actually came from Florida. So this is coquina. And then number 26, rocks that have been all thrown together. We call these conglomerates and breccias. In this case, this is a breccia because the clasts that make up this rock are angular, or square. The opposite of a breccia is going to be the conglomerate, and we'll see one in a minute. But first we're going to stop off and see Mr. Hematitic sandstone here. So this is hematic sandstone. It's red in color due to iron oxide. It's basically composed of quartz sand and some iron oxide. Very fine grain, very uniform, well sorting. That means all the grains are the same size. And that we call hematic sandstone. That was number 27. Number 28 is the conglomerate. You can see that the clasts that make up this rock are rounded, all cemented together. That's a conglomerate. Kind of looks like concrete because basically that's what conglomerates are. They're nature's natural concrete. Number 29. This is a sandstone. That's a very dirty sandstone, not very well sorted. It has big pieces of potassium feldspar in it. You can see the pink case bar in it. So anytime you see pink pieces of potassium feldspar in it, that is what we call an Arcos sandstone. Number 30. Very fine grain, formed in a billabong or a lagoon. This is actually a piece of chalk. It writes on tables and everything else. All right, one last rock group, and that is the metamorphics. So you take a piece of shell, you subject to heat and pressure, you're going to get number 31. So the first metamorphic rock we have here is a piece of slate. Slate's parent rock is actually a shell. Shell, claystone, siltstone. When they're metamorphosed, they form this nice rock called slate. Next rock, number 32, has a little bit of a wavy texture, a slight shine, but no visible minerals, much like its counterpart, the slate. The phyllite has a little bit of a shine to it, a little bit of sheen to it, and a little bit of wavy texture. That is a phyllite, and its parent was the slate. So slate metamorphosed to form phyllite. And then phyllite is going to metamorphose to form this rock here, schist. So this is schist, a bunch of minerals all kind of together. This thing is full of micas. You can see the muscovite and the biotite in here. Very rich in the mica minerals. And then after that, we now go into a rock that is about 98% amphibole. These are fine grain amphibole minerals, all thrown together. So we take the mineral amphibole, and we put it into a rock, and we call it amphibolite. So this is an amphibolite. Nice and layered, has almost like foliation look to it. And it is considered one of the foliated rocks. And the highest degree of metamorphism is this one right here. This is a piece of gneiss. This is a very nice piece of gneiss. You can see the layering effect here. So the white mineral is plagioclase, and the black mineral is amphibole. You can see this alternating layers. You'll often see this rock in pink and black. So the black being amphibole, and the pink being potassium feldspar. This rock here is considered foliated, but it's kind of a tricky one for a lot of students. This is actually a piece of greenstone. Its counterpart is going to be green schist. So this is green stone. It doesn't really have any foliation, not much layering to this rock at all. It's mostly massive. That's typically what you see in green stone. This is actually a green schist. You can actually see the layering in this rock. Well foliated, definitely layered. So this is green schist. Okay, let's finish up with the metamorphics. We have 3 more to do over here. Very shiny rock, very black. This is what we call anthracite coal. So anthracite coal is similar to the bituminous coal, except this is more pure carbon. This has been subject to heat and pressure. The sulfates have been driven out, and we're basically left with almost pure carbon. So that's a carbon-rich coal, and that we call anthracite coal. Very shiny. Right over here we have a repeat. This is another schist. But this I would actually classify as a garnet schist. You see the little red things in here? Those are garnets. So this rock is loaded with garnets and muscovite. So this is basically a garnet schist, or it's just a schist in our case. And a rock that reacts to acid, that's parent was a limestone. This is actually marble. So what's the difference between marble and limestone? Is that when limestone is metamorphosed, it turns into marble. So the parent of this rock is a limestone, but the small little microscopic calcite minerals actually begin to crystallize and form. They grow, and this basically is how this marble was formed. So that ends the review for Rock and Mineral Exam 2025.